Hello, good afternoon. Now today, let us start the other important or major topics in chemical engineering, which is called as chemical engineering reaction, chemical reaction engineering, which is directly given by Lataliso, a lecturer and a researcher at HARAMAYA University, Department of Chemical Engineering, HARAMAYA Institute of Technology. Actually, there is uh, a huge gap in understanding the chemical reaction engineering. That's why let us directly prepare questions. Let us directly prepare the main topic explanations related with what are the chemical reaction engineering, what are the application areas of chemical reaction engineering. In addition, the classification of chemical reaction engineering for most of chemical and the process industries. Now let us start the contents of the lesson. The contents of today's lesson directly focuses on the definition of chemical reactor, application of chemical reaction engineering, and the different classifications of chemical reactors. Now let us proceed into what is actually the definitions of chemical reaction engineering. Chemical reaction engineering is the branch of engineering that encompasses or that contains the selection, design, and the operation of chemical reactors. Actually, this course deals with the operability of the chemical reactors while performing or while transforming the raw materials into desired products as well as undesired products. Through the process, there is a conversion of undesired products, which means the recycling of undesired products into the desired products. In addition, the chemical reaction engineering encompasses or contains or includes many diverse concepts. Concepts directly related with the concepts related with what we call it chemical kinetics, chemical reactors, as well as the concepts related with the design of chemical reactors. In addition, principles and the methods. There are the principles, methods, or what we call it how. Know how to design reactors, know how to perform the chemical kinetics that cannot be covered in that cannot be covered adequately in a single volume due to the diversity of chemical reactor applications. There are different applications of or diverse applications of chemical reactors in chemical and the process industries through the use of what we call it, especially on the mode of operation. There is batch reactors, continuous reactors. The wide spectrum of operating conditions. Actually, those operating conditions in relation with volume, in relation with flow rate, the molar flow rate, and the other parameters. But the main focus is on through the operating conversion, increasing the conversion of the product, which means that the rate at which the reactant is just transformed into the product, and the multitude of factors that affect the reactor operations. There are different multitude operation factors that affect the reactor operations. One multitude factors is the temperature, pressure, and the fluctuation or what we call it the change in concentration of the reactors, concentration of the reactants within the given within the reactors. A chemical reactor is an equipment unit. What we call it? It is a unit in which is a chemical process or a plant where the chemical transformations or reactions take place to generate the desirable product at a specified production rate. So the chemical reactor is a place where the chemical reactions takes place, or the place where the chemical transformations or the unit processes are takes place is considered as a chemical reactor. In chemical engineering, the chemical reactor is the heart of chemical processes because all transformations. all transformations, which means that the chemical transformations or reactions is directly takes place in a given chemical reactors. The reactor configuration and its operating conditions are selected to achieve a certain objective, such as maximizing the profit of the process. In chemical reactor or in chemical reaction, what we call it is maximizing the profit of the process means increasing the rate of products or increasing the production rate, what we call it increasing the conversion of the reactants into the products. The other one is minimizing the generation of the pollutants, since the pollutants affects or the release of the pollutants into the environment directly affects human beings, which means that social, economical, as well as other parameters. Is important to minimize the generation of the pollutants or recycling the pollutants into the desired product while satisfying several design and operating constraints. So consideration of safety, controllability, and availability of the raw materials are actually it is very important in reactor configuration as well as its operating conditions all in order to achieve a certain objectives. Usually the performance of the chemical reactor plays a pivotal role in the operation and the economics of the entire process. So directly the performance of the chemical reactor related with the operation as well as the economics of the entire process. The economics of the entire process means normally checking the feasibility of the process, whether it is feasible or not within the integration of the different chemical reactors. The chemical reactors should fulfill three main requirements. In chemical reaction engineering, three things should be fulfilled, or in chemical reactors, three things or requirements should be fulfilled. The first one is it should provide appropriate contacting of the reactants. The reactants should be contacted or mixed at appropriate rate. The second one is it should provide the necessary reaction time for the formation of the desired product. The reaction time means it is important to increase the rate of the chemical kinetics. Because the rate is directly related with time. So the rate of reaction directly related with the product as well as the reactant. So it is necessary to provide reaction time for the formation of the desired product. The third one is provide the heat transfer capability required to maintain the specified temperature range. So within the specified temperature range, it should enhance the heat transfer rates. Not only heat transfer, it also enhance or it also provide the mass transfer rates. The mass transfer rates within the different types of chemical reactors. In many instances, these three requirements are not complementary, which means that those three things are not complementary in chemical reactors. Achieving one of them comes at the expense of another. So if you achieve one objective, which means that, for example, providing what we call it the conversion of the reactants, providing what we call it getting a high rate product. So this one is, for example, if you consider this one, you can consider it as achieving this one from the three requirement is actually, if you take it as an important, is important in accordance with your ideology. So chemical reaction engineering is concerned with achieving these requirements for a wide range of operating conditions such as different reacting phases. Different reacting phases means for solid reactions, for liquid reactions, as well as for gas reactions. So it is important to maintain the reacting phases. The second one is different reaction mechanisms. Either those reactions is catalytic reactions or non-catalytic reactions. So catalyst-based reactions and the non-catalytic based reactions. Catalytic based reaction means the rate of the product is high, which means that the rate at which the product is achieved is maximum. In non-catalytic reactions, it may takes the states. It may take states or gaps or barriers in order to get the desired products. The third one is different operating temperature and the pressure. Different operating temperature and the pressure, which means that either for systems, which means that there is a physical mechanisms, either is a chemical reactions or what you call it biological reactions. So for those biological reaction utilizing a low temperature system. For example, most of the catalytic reaction, if you use enzymes, it may operate up to 35 degrees Celsius temperature. High temperature for many reactions, especially in hydrocarbon processing, especially in petroleum application, we can use a high temperature for many reactions in hydroprocessing as well as in petroleum processing. So this is normally the concernation or the what we are going to achieve in chemical reaction engineering in aspects of different views. The subject chemical reaction engineering initiated and involved primarily to accomplish the task of describing. Actually, the chemical reaction engineering accomplishes different tasks of describing or initiated and evolved primarily to accomplish the task of describing how to choose or how to select, how to size, actually how to size directly related with volume, how to choose directly related with the process conditions. It may be process conditions or maybe it is types of reactors and so on. How to determine the optimal operating conditions. The optimal operating condition either the maximum conversion rate or the minimum conversion rate or what we call it optimization of the process conditions for a reactor whose purpose is to produce a given set of chemicals in a petrochemical applications. This one is directly related with the configurations of different reactors depending on either the reaction mechanisms or depending on what we call it the design of reactors, either for series reactions or for parallel reactions or for series configurations or parallel configurations. So these are the very important in the subject of chemical reaction engineering in order to accomplish a given task or in order to finalize or in order to describe the given tasks. So chemical reactors are commonly classified by three main characteristics. Actually, in this session or in this lesson, the chemical reactors are classified into three main characteristics. The chemical reactors are classified into uh, different components depending on three main characteristics. The first one is depending on the mode of operation. Depending on the mode of operation, the chemical reactors can be classified as batch reactors and continuous reactors, or it means semi-batch reactors. From continuous reactors, there is continuous think tank reactor and a plug flow reactor or tubular reactor. The second one is depending on geometric configuration. There are tubular reactors, agitated tank reactors, radial flow reactors. Again, depending on the contacting patterns between phases. Contacting patterns between phases means either with liquid with gases or gases with gases or what we call it solid with gases. Such types of reactors can be partly bed reactors, fluidized bed reactors, bubble column reactors, or Kiln reactors are the reactors which is classified based on the contacting patterns between the phases. In addition, reactor operations are also classified by the way their temperature or heat transfer is controlled. Depending on the way in which the reactor in which the temperature or what we call the heat transfer is controlled, they can be classified as isothermal operation, which means that the reactors which operate at constant temperature, adiabatic operation, which means that the reactors at which there is no heat is transferred into the system or out of the system or out of the reactor. The third one is non-isothermal operation. The operation is neither isothermal nor adiabatic. What we call it? The system is operating at a non-constant temperature, which means that there is the fluctuation of the temperature at the given time. within the given reactor. These are the three operational conditions depending on the temperature or the heat transfer is controlled. So let us see one by one. Batch reactors. Batch reactors are the types of reactors which are classified based on the mode of operations. So in batch reactors, the reactants are charged into a vessel at the beginning of the operation and the products are discharged at the end of the operation. So in such reactors, the there is the charging of the reactants and the discharging of the products from the reactors. So the change in parameters, which means, for example, if we take concentration with respect to time, is just different from zero, which is the accumulation is not zero. So the chemical reaction takes place over the time. So the chemical reaction, in order to analyze the chemical reactions, it needs what we call it time, which means that some parameters with respect to time is not constant, which is free from zero. The vessel is usually agitated to provide a good contacting between the reactants and to create a uniform conditions, for example, concentration and temperature throughout the vessel. So the vessel is what we call it agitated. Yes, there is an agitation in the vessel, and as well as the vessel is what we call it jacketed in order to just or insulated in order to omit or reduce the release of the heat to the environment. So this helps such type in such types of reactors. There is a transfer of what we call it heat. The transfer of the heat as well as it enhances the heat transfer mechanism as well as the mass transfer mechanisms. So this one is actually shown in figure 1.1, which means that this one is actually considered as figure 1.1. This one is considered as a batch reactor. A batch reactor, there is the charging of the reactants and the discharging of the products over the given time is considered as the batch reactors. The other is semi-batch reactors. In semi-batch reactor, once the one reactor is charged initially and another reactor is just reactant is added continuously during the operation. So this one is there are two operations or two mechanisms. In the first, one reactant is initially charged into the reactor. The other one is, or the tank is charged with one reactant. On the other hand, the another reactant is added continuously during the operation. Such types of reactant is considered as semi-batch reactors, which means that having the features of what we call it batch reactors and having the features of continuous reactors is considered as semi-batch reactors. This mode of operation is used when it is desirable to maintain one reactor, which means that the injector reactant at low concentration to improve the selectivity of the product and to supply or remove the heat. So such types of reactors is utilized for improving or enhancing the selectivity of a desirable product as well as to remove or to supply the heat, which means that there is unwanted heat or required heat or the supplied heat to the system. So during such mechanisms, we can use what we call semi-batch reactors. The third one is distillation reactors. A batch reactor where volatile products are removed continuously from the reactor during the operation is known as a distillation reactor. Actually, there is the continuous production of what you call it the volatile products is considered as distillation reactor, which means that it looks like the distillation columns. The fourth one is continuous reactors or flow reactors. So these continuous reactors or flow reactors can be classified into two: continuous tank reactor and the black flow reactor. So in this continuous reactor, a vessel into which reactants are fed continuously and the products are withdrawn continuously from it is considered as continuous reactor. There is a continuous feeding of the reactants and the continuous withdrawal of the product is considered as the continuous reactor. The chemical reaction take place over the space or the reactor volume, and the residence time of the reactive fluid in the reactor provides the required reaction time. So here we are going to consider the residence time, the time that is required for the reactions, the time required for the reactions, or it measures the period of the reaction, what we call it the residence time. Residence time. So this reaction is actually this is what we call it. B is semi-batch reactor. C is it looks distillation reactor, which means that it has its own condenser as well as evaporator for what we call it cooling and heating medium, as cooling and heating medium. So that's the common configuration of reactors. Actually, in continuous reactor, there is a tubular reactor or plug flow reactor, continuous tank reactor, cyster, and a cascade of continuous reactor, cascade of either different, which means that multiple reactors are connected together, what we call cascade reactors. For multi-phase reactions, the contacting patterns are used as a basis for classifying the reactors. If there is a multi-phase reaction mechanisms, which means that either those reactions are in series or in parallel, the contacting patterns are used as the basis for classifying the reactors. The common configurations include the common configurations of what we call it depending on what we call it the contacting of the different phases, either solid with gases or solid with liquids or liquid with gases. They may be classified as packed bed reactor, moving bed reactor, fluidized bed reactor, and electrical bed reactor. Mostly those reactors are used in gasification systems. During the production of what we call it the gases, using the production of the gas, what we call it the synthesis gasification of especially for the biomass. So A is not actually considered as the tubular reactor, what we call the plug flow reactor. B is considered as what we call it the continuous tank reactor. There is a continuous feeding of the reactor and the continuous withdrawal of the product is considered as the continuous steel tank reactor or CSTR. The third one is continuous reactors in in connection. What we call is there is a connect cascade reactors, means different reactors or the multiple reactors connected together. What we call it is a cascade reactor. Especially this is very since what we call is the overall conversion of the overall conversion is or the rate of the conversion over the volume is low. We can increase the rate of conversion by just connecting those reactors. We will see in the upcoming lessons about what we call it, what is the advantage of chemical, what is the advantage of continuous tank reactor, disadvantage of continuous tank reactor. The same is true for batch reactor and the plug flow reactors. So packed bed reactor. In a packed bed reactor, a vessel filled with catalytic pellets. So the vessels, what we call the packed bed vessels, is just filled with catalytic pellets, and the reactive fluid is passing through the void space between them. So the reactive fluid is, for example, consider this one is the bed, which means that having different pores. So the reactive fluid is just directly passes through the void space, which means that the voids, what we call it, those pores, which is made from what we call it different, what we call it the nanomaterials, is just it helps for passing of the fluids through it. So relatively large pellets, which means that large pellets means larger than 1 centimeter, are used to avoid excessive pressure drop and high operating costs. So we can use the pellets which is relatively larger than 1 centimeter in order to avoid or omit the excessive pressure drop as well as high operating cost. In general, heat transfer to or from large scale packed bed reactors is a challenge because it may cause what we call it the it causes heating. Heating of those materials is may damage. It may damage. So that's why heat transfer to or from a large scale but packed bed reactors is a challenge. The other one is there is a moving bed reactor, a vessel where solid particles, which means that those solid particles are either reactant or catalyst, are continuously fed and withdrawn from the reactor is considered as a moving bed reactor. So A is considered, this one is considered as what we call it a packed bed reactor. A packed bed reactor. So normally there is a coolant. This one is a coolant for cooling mechanism. There is a gas in. This one is the product. So this one is a packed bed. Through this packed bed, which means that it has this bed has its own hole, what we call it void space, which is used for the passing of the reacting fluid through this packed bed. So the reaction mechanism is just takes place inside the packed bed reactor. So this is considered as a packed bed reactor. The other one is a moving bed reactor. In a moving bed reactor, there is an entrance of what we call the reactant, which means the gas is in. There is additionally there is also what gas out, which means the product. So the solids, which means that there is a contacting of the solids with a gas in order to make what we call it the fluidized system. In order to make the fluidized system, which means that there is a contacting of gases with the solids in order to make a fluid bed within a fluid bed or in order to make the reacting molecules. So the gas flow is maintained to allow the downward movement of the particles. So the solid particles are just continuously fed and withdrawn from the system. In a moving bed reactor, the fluidized bed reactor, a vessel filled with fine particles, which means that those fine particles are smaller than 500 mm that are suspended by the upward flowing fluid. The second one is the fluidized bed provides a good mixing of the particles and it controls the temperature of the system, which means that the temperature of the system throughout the fluidized bed reactor is constant. So figure C, which means that this one is considered as a fluidized bed reactor. Which means that there is a fluidization process. A fluidization process means there is the contacting patterns of the solids with gases or the liquids with gases. Through this process, the fluidization process or the fluidization mechanisms takes place through a fluidized bed reactor. The other one is trickle bed reactor, a packed bed where a liquid reactant is fed from the top, wetting catalytic pellets, and a gas reactor feed either from the top or the bottom, flows through the void space between the pellets. So here, the liquid reactant is just directly fed from the top. So the purpose of the liquid reactant is just utilized for wetting a catalytic pellets and a gas reactant feed. Normally those catalytic pellets, which means that the wetted catalytic pellet as well as a gas reactor feed either from the top or from the bottom, flows through the void spaces between the pellets. So consider this one is a trickle bed reactor, in which the liquid reactant is directly fed from the top. This one is for liquid reactant. So actually the gas as well as the catalytic pellets may be utilized or feed from the top or from the bottom, and the flow takes place through the void spaces between the pellets. So this is actually it is called as the trickle bed reactor. There is a packed bed. So within a packed bed there is what we call as the reaction mechanisms, what we call it the liquid reactant contacted with catalytic pellets as well as the gas reactants. The second one is a gaseous reactant must be absorbed and transported across the liquid film to the catalytic sites at the surface of the pellets. So there is an absorption of the gaseous reactant, and the absorbed gaseous reactant is directly transported across the liquid film to the catalytic sites at the surface of the pellet. So the reaction mechanisms takes place. Such reaction mechanism takes place in triple bay reactor. The other one is a bubble column reactor. In bubble column reactor, actually in D, so there is a continuous supply of liquids from the bottom as well as gases from the bottom. So reacting mechanism takes place within a bubble column. It forms a bubble. There is mixing of the liquids with the gases. So the bubble is formed inside the bubble column reactor. A vessel filled with a liquid reactor and a gas reactor feed from the bottom moves upward in the form of bubbles. It forms what we call the bubbles. Bubbles, which means that a low density liquid. The liquid reactant is fed from the top and withdrawn from the bottom. The gaseous reactant is absorbed in the liquid reactant and the reaction takes place in the liquid phase. So there is what? The absorption of the gaseous reactant in the liquid reactant, and the reaction mechanisms takes place in the liquid phase. So such mechanisms takes place or occur or exists in bubble column reactors. So this type of reactor is what we call it a bubble column reactor. In A, we can consider a spray reactor. So there is uh, what we call it gases inside the reactor. There is gases in the reactor. On the gases, we spray what we call it liquid. We spray liquid. So through spraying the liquid on the surface of the gas, the reactions or due to such contacting, the reaction mechanisms or the reaction process takes place. So this is a multi-phase reactor, what we call it a kiln reactor. Most of the times those kiln reactors exists in what we call the process industry, what we call is the cement industries, because there is a solids. The solids is directly reacting with hot gases in order to produce the desirable product. Such types of reactor is known as a kiln reactor. So for this as references, you can use Chemical Reaction Engineering textbook by Octave, as well as textbook of Chemical Reaction Engineering by Fogler. Additionally, you can use a textbook of Chemical Reaction Engineering written by Govani, very important textbook, which is used for especially for further analysis of chemical reaction engineering. Thank you for your attention.